If you could go back in time, what would you change? This is a question everyone has probably thought about at least once. Is time travel just a fantasy found in movies and novels? Or is modern science on the verge of making it a reality? In this video, we will thoroughly explore the truth of this possibility of transcending time by making full use of the latest physics theories, experimental results, and philosophical considerations. What is the nature of time? Is it theoretically possible to go to the future? What are the paradoxes lurking in a journey to the past? What would happen to humanity and society if we could manipulate time? And what about the cutting-edge time machine research that scientists are tackling? Please join us to the very end on this magnificent journey of time exploration that will stimulate your intellectual curiosity. When this video is over, your perspective on time may change. What is the true nature of time? First, as a foundation, let's delve into the mysterious identity of what time is. We usually use expressions like, "Time flew by in an instant," or "Time is passing slowly." It feels as if time is flowing smoothly like a river. But is time really flowing? Or is the feeling that it is flowing merely a trick of the human brain? Understanding the essence of time is a prerequisite for any discussion of time machines. The theory of relativity shows us that time can stretch and shrink. In the early 20th century, Albert Einstein revolutionized our concept of time. According to his special and general theories of relativity, time is not the absolute and universal constant we intuitively believe it to be. For example, what would happen if someone flew into space on a high-speed rocket and then returned to Earth? The person who traveled to space would be younger than the person who remained on the ground. This example might seem a little extreme, but this phenomenon of time dilation is not just a fantasy. It has been scientifically proven. Einstein's theory states that the faster you move, or the stronger the gravitational field you are in, the slower time passes. In fact, experiments have confirmed that when an atomic clock is flown on an airplane, it runs slightly slower than a clock on the ground. Furthermore, it has been demonstrated with ultra-precise atomic clocks that a difference in altitude of just 33 centimeters causes a difference in the passage of time, with the clock at the higher elevation running faster, even in our everyday technology. This effect cannot be ignored. GPS satellites orbit the Earth at high speeds and are in a weaker gravitational field. So their clocks must be constantly corrected for the time difference with the ground to provide accurate positioning. Amazingly, time stretches and shrinks depending on location and speed. In other words, the phenomenon of time slowing down is a reality predicted by Einstein and confirmed by modern experimental science. So, what does it mean for time to stretch and shrink? Let's consider a familiar analogy. Imagine the twin paradox, sometimes called the Urashima effect, after the old Japanese tale of Urashima Taro. Suppose there are twin brothers. One stays on Earth, while the other travels into space in a rocket moving at nearly the speed of light. When the traveling brother returns after a few months in space, many years have passed on Earth, and his brother has become a middle-aged man. This is exactly like the situation in the story of Urashima Taro. While creating such an extreme difference is not feasible with current technology, there are experimental examples of astronauts time traveling into the future by a tiny fraction of a second. Russian cosmonaut Sergei Avdeyev, who spent a cumulative record of 747 days on the space station, is reported to be about 0.02 seconds younger, having traveled that much further into the future than if he had stayed on the ground. You might think that's just a few hundredths of a second. But he is the person who has traveled furthest into the future in human history. This eloquently demonstrates that time is not absolute, but changes depending on conditions. As the theory of relativity tells us, the world of quantum physics suggests that time does not exist, while the theory of relativity revealed the relativity of the passage of time. The challenges of physics have pushed even further. In fact, some theoretical physicists are even debating whether time itself is an illusion. For example, in loop quantum gravity, a quantum theory of gravity, time is no longer considered a fundamental reality. The theoretical physicist Carlo Rovelli points out that the flow of time we perceive is merely a human subjectivity, and the variable of time does not appear in the fundamental equations of physics. According to Rovelli, the world is not made of particles and fields, but a network woven from events, and time is nothing more than what emerges from the correlations between these events. For instance, the reason we perceive a present, past, and future might be because the thermal disorder, or entropy, of the universe is increasing, creating a direction from cause to effect, and our brains simply interpret it that way. Astonishingly, at the forefront of physics, the bold hypothesis that time is an illusion and does not fundamentally exist is being considered. Of course, not all scientists agree with these assertions. The idea from loop quantum gravity that time is not fundamental lacks experimental evidence, and there are skeptical voices. However, what can be said, at the very least, is that time is a stranger concept than our intuition suggests. The absolute time that had been taken for granted since Newton, flowing at the same rate everywhere, was negated by the theory of relativity. Meanwhile, in the world of quantum theory, the very possibility that the concept of time could blur or even disappear is being discussed. Synthesizing these findings, the flow of time we experience in our daily lives may be a kind of mask, shaped by our human sensory experience. Tearing off that mask to understand the true nature of time is extremely important as a foundation for the discussion of time machines. The possibilities of travel to the future, as depicted by science. All right, let's finally dive into the concrete possibilities of time travel. First, we'll take up the topic of traveling to the future. Intuitively, moving forward into the future seems perfectly normal. In fact, all of us are moving into the future, second by second. However, what we are discussing here is a jump into the future that goes beyond this normal flow. By utilizing the effects of the theory of relativity, which I touched upon earlier, it becomes theoretically possible to make a significant leap into the future. The key to this is the phenomenon of time dilation, a jump to the future brought about by high speeds and gravity. As explained in the previous chapter, we know that the closer you get to the speed of light, the slower time passes. We also know that in the presence of strong gravity, time slows down. If we could utilize these principles to their absolute limits, it would be as good as having a one-way ticket to the future. For example, speaking purely theoretically, let's say you took a space journey at the incredible speed of 99.999% of the speed of light and spent 10 years doing so. When you return to Earth, it's possible that hundreds, even thousands of years have passed. For the astronaut, it was only 10 years, but on Earth, they have arrived in the distant future. This isn't science fiction. It's a phenomenon permitted by the theory of relativity. while a rocket capable of such high speeds doesn't exist yet. This is a phenomenon that occurs daily for subatomic particles inside particle accelerators. A particle called a muon, which travels at high speeds, has a lifespan of only about 2 microseconds, or 2/1 millionths of a second. However, when accelerated to near the speed of light in an accelerator, its lifespan, as observed by us, has been seen to extend by several tens of times. In other words, high-speed movement definitely has the effect of slowing down time, which is equivalent to moving into the future. We can also consider methods of going to the future using gravity. The prime example of this is a black hole. A black hole has an extremely large mass and powerful gravity, causing time to be significantly warped in its vicinity. Near the event horizon of a black hole, the boundary where everything is sucked into the black hole and cannot return, time slows down so extremely that a single moment spent there is equivalent to an eternity in the outside world. For example, let's imagine a friend of yours unfortunately falls into a black hole. As you watch your friend from a safe distance, their movements will gradually slow down, and near the event horizon, it will look as if time has completely stopped for them. In reality, your friend falls in over a finite amount of time, but from the outside, it appears as if they are eternally frozen at the event horizon. If we were to assume you could observe your friend indefinitely, they would appear to remain stopped near the event horizon until the end of the universe. This is an extreme consequence of the general theory of relativity, where immense gravity drastically stretches the surrounding time. By using this phenomenon, it is theoretically possible to travel to the future. It's an extreme example, and one that doesn't mind a suicidal act. But a scenario could be conceived where you whip around a black hole at high speed, just grazing its vicinity, and then return. By doing so, you would not have aged much yourself, while the outside world would have advanced far into the future. The movie Interstellar depicted a setting where 1 hour on a planet near a black hole was equivalent to 7 years on Earth. And that is precisely this effect. In reality, approaching a black hole is extremely dangerous. But a safer method might be to orbit a high-gravity celestial body, such as a neutron star, at high speed. In any case, slowing down your own time through high speeds or gravity is the key to future travel. Future travel is already moving from theory to reality. As we have seen so far, time travel into the future is permitted by the laws of physics. Albert Einstein's theory of relativity guarantees it, and we already utilize minute time discrepancies in our daily lives. This means that if we can clear the technological hurdles, such as building a rocket that can approach the speed of light or harnessing immense gravity, it is not a pipe dream for humans to make a significant jump into the future. The term time machine may sound dubious, but as far as travel to the future is concerned, it is a phenomenon that lies on an extension of already established scientific theory. In fact, as mentioned at the beginning, there have been examples of astronauts who flew at high speeds and returned younger than they would have been on the ground. And experiments have been conducted where time on aircraft, flying at high altitudes, runs slower than on the ground. Although the scale is small, time travelers, in a sense, already exist. The renowned physicist Stephen Hawking has also made statements to the effect that time travelers are already here, and that the astronauts are the ones who have traveled farthest into the future on Earth. Professor J. Richard Gott, in his book, states that time travel is by no means a product of fantasy. It requires considerable energy and effort. But it is physically possible for scientists. Time travel to the future is a realistic theme worthy of serious consideration. Is a trip to the past possible? Now that we've figured out that traveling to the future is possible, let's tackle the theme that really captures our imagination. Journeying back in time, if we could go to the past, could we rewrite history itself? Is something like that even allowed by the laws of physics? Well, as it turns out, science has come up with some bold hypotheses and theories to answer that very question. Wormholes, a shortcut through space-time. When we talk about ways to go to the past, the idea of a wormhole often comes up as a leading candidate. In a nutshell, a wormhole is a shortcut through space-time. It's a hypothetical passage, like a tunnel, that could connect two distant points in space, or even two different points in time. It's a concept derived mathematically from Albert Einstein's general theory of relativity. If you think of a black hole as punching a single hole in space-time, a wormhole is like a tunnel connecting two of those holes. If we could successfully navigate this tunnel, it might be possible to travel through space or time faster than the speed of light. In fact, back in 1935, Einstein and his colleague Nathan Rosen published a paper suggesting the existence of these bridges through space-time. Applying the principles of black holes, this became known as the Einstein-Rosen bridge. Later, the physicist John Wheeler coined the term wormhole, and it became a widely known concept, especially in science fiction. One scenario for using a wormhole as a time machine involves manipulating the flow of time at either end. For instance, you could take one mouth of the wormhole and move it at nearly the speed of light, or place it in a strong gravitational field. This would cause time to slow down at that end, creating a time difference between the two mouths. For example, if you put one end of a wormhole on a high-speed rocket and sent it on a round trip through space, time at that end would slow down. If you then reconnected it with the other end that remained stationary, there would be a time gap between the two mouths. So, if you entered one side and exited the other, you could emerge in the past. It sounds strange when you say it out loud, but the idea is to combine the time dilation effect from the theory of relativity with a wormhole to make travel to the past a reality. In the 1980s, physicist Kip Thorne and his colleagues explored this idea in a paper, showing that a wormhole could indeed function as a time machine. However, there are some major hurdles with this method. First, wormholes themselves are still purely hypothetical, and even if they do exist, keeping a traversable wormhole, one that people or objects could actually pass through open, would require a special kind of matter with negative energy, known as exotic matter. Still, wormhole theory is a cutting-edge field that is being seriously researched today. It's not just a fantasy. There are even simulation studies being conducted on what would happen if we could artificially create a wormhole and hold the gate open with exotic matter. Institutions in the West, including NASA, are exploring some of these concepts. Time machine solutions, permitted by general relativity. Besides wormholes, Einstein's theory of general relativity allows for other bizarre time machine solutions. In 1949, Kurt Gödel, famous for his work as a logician, discovered a solution for the universe where the entire cosmos is rotating. This creates closed time-like curves, which are essentially looping paths in time. In Gödel's universe, you could travel along a certain path and end up back in your own past. This is, in effect, a universe-scale time machine. Inspired by this discovery, physicists began searching for other time machine models. For example, Frank Tipler proposed the Tipler cylinder, a hypothetical, infinitely long and super-dense cylinder spinning at incredible speeds. The idea is that this spinning would twist space-time so much that it would form closed time-like curves. There's also a proposal from Richard Gott, which suggests that if you could get two hypothetical cosmic strings to fly past each other at high speeds, time could loop back on itself. Mathematically, the general theory of relativity doesn't forbid travel to the past. In fact, solutions like Gödel's universe, the Tipler cylinder, and traversable wormholes are theoretical proof that if you can create causal loops, you can travel in time. In other words, these solutions suggest that if we could control gravity sufficiently, time travel would be possible. However, these are all theoretical concepts for now. The idea of preparing an infinitely long, super-dense cylinder, or using cosmic strings, let alone stabilizing a wormhole that a person could pass through, is far beyond our current technology. But the key point is that the laws of nature themselves do not explicitly forbid journeys into the past. Because of this, the possibility of time machines is not just laughed off. It has become a serious topic of research for theoretical physicists. The study of time travel is not just science fiction. It's an active attempt to understand the views of real physics. And research is thriving today. The time paradox and the struggle of scientists. When it comes to time travel to the past, there's a problem we absolutely cannot avoid. That's right, the time paradox. Perhaps the most famous one is the grandfather paradox. It goes like this: if you went back in time and killed your own grandfather when he was a child, you would never have been born. But if you were never born, then who killed your grandfather? This is the most fundamental problem caused by time travel, as it shatters the law of cause and effect, leading to a self-contradiction in the universe. The journey to the past is always shadowed by this massive problem of causality breaking down. Scientists have debated various solutions to this dilemma. One idea is that the past simply cannot be changed. The Russian physicist Igor Novikov proposed the self-consistency principle. He argued that no matter what a time traveler does, their actions are already part of history. Simply put, this idea suggests that even if you travel in time, you can't alter the past. History will always resolve itself without any self-contradictions. According to this hypothesis, if you went back in time to try and kill your grandfather, something would prevent you from succeeding, and the paradox would be avoided. In a way, it's a very convenient solution, but it's also a form of determinism that denies our free will. It makes you wonder what the point of going to the past in a time machine would be if you can't interfere. But it is one theoretical solution. Another famous idea is the introduction of parallel worlds. This concept suggests that the moment you make a change to the past, a new history branches off from the original world, and a new future unfolds based on that change. In the grandfather paradox scenario, the new world would branch off where your grandfather dies, and you are never born. Meanwhile, the original world, the future you came from, remains completely unchanged. This avoids any contradiction. However, in this case, the time traveler can never return to their original world. The moment they change the past, they become an inhabitant of a different world. Many science fiction stories have adopted this parallel worlds setup, and it aligns well with the many worlds interpretation of quantum mechanics, also known as the Everett interpretation. However, whether parallel worlds physically exist is still a matter of debate, and some point out that the creation of a new world might violate physical laws like the conservation of energy. For now, it remains a thought experiment level solution, but it's a powerful scenario for avoiding time paradoxes. Furthermore, recent research has suggested that history might have a way of self-correcting to prevent paradoxes from happening in the first place. According to a paper published in 2020 by physics students at the University of Queensland in Australia, it was mathematically shown that even if a time traveler could act with free will, any action that would cause a paradox would be automatically corrected, leading to a consistent outcome. For example, if you went back in time to prevent a pandemic, the disease might end up spreading in a different way, but the overall course of history would remain unchanged. It's as if some kind of adjustment mechanism is at play. It feels a bit strange. But this research presents a middle ground solution, suggesting that while the past can be changed to some extent, causality will not be violated. This is a noteworthy point in the latest research on time machines. Finally, I want to touch on Dr. Stephen Hawking's chronology protection conjecture. In a 1992 paper, Hawking proposed that the laws of nature might work in a way that prevents closed time-like curves, or time loops, from forming. Simply put, his argument was that time machines probably won't appear in our universe. If they did, we would have already been visited by people from the future. There's a famous story where Hawking, half-jokingly, threw a party for time travelers and sent out the invitations after the party was over, addressed to the future. When no one showed up on the day of the party, he said something like, "See, no time travelers ever came." His conjecture has neither been proven nor disproven, but the idea that nature acts as a guardian to protect causality has some merit. Perhaps some unknown quantum gravity effect would cause a time machine to break down the moment it tried to operate. Time travel to the past is, as you can see, a tightrope walk between science and logic. General relativity allows for it, but trying to make it a reality leads to paradoxes. Scientists have been tackling this contradiction with various hypotheses, but there's no definitive answer yet. Is a journey to the past possible? Right now, that's a question no one can answer. But one thing is certain: by tackling this difficult question, our understanding of physics deepens, and humanity gets one step closer to uncovering the secrets of the universe and time itself. The forefront of modern experiments, talk of time machines might sound fantastical, but in reality, this topic is still being seriously studied by scientists all over the world. Here, I'd like to introduce some of the most notable recent research and experiments as of 2025. Even if you think time travel is just science fiction, your perspective might change. The cutting edge of wormhole research. As mentioned earlier, wormholes are a leading candidate for a time machine, but so far, none have been directly observed. Nevertheless, it's a hot topic in the field of theoretical physics. What's been getting particular attention in recent years is the strange connection between wormholes and the quantum world. In 2013, physicists Juan Maldacena and Leonard Susskind proposed a bold hypothesis called ER equals EPR. EL, stands for Einstein-Rosen, as in the Einstein-Rosen bridge. Or wormhole, EPR, stands for Einstein-Podolsky-Rosen, as in the quantum entanglement experiment. Their idea is that the seemingly unrelated theories of black hole wormholes and the phenomenon of quantum entanglement might be equivalent. They suggested that particles that are very strongly quantum entangled are connected by a thin wormhole of sorts. Developing this idea further, another theory emerged that it might be possible to create a traversable wormhole, one that people or things can pass through by injecting negative energy. In this scenario, quantum teleportation and travel through a wormhole could be described as the same phenomenon. It sounds like something out of a dream. But experiments are actually being conducted to try and verify this hypothesis on a small scale. In 2022, a team from the California Institute of Technology and Harvard University announced that they had successfully simulated the behavior of a wormhole. Using Google's quantum computer, they created a quantum state on the quantum processor that was equivalent to a small black hole and used quantum teleportation technology to successfully transfer information as if it had passed through a wormhole. They also observed behaviors consistent with wormhole theory, such as information being able to pass through when an operation equivalent to negative energy was applied, but not when it wasn't. Of course, they didn't create a real tunnel in space. They only reproduced a phenomenon equivalent to a wormhole in a quantum state. But this is considered a groundbreaking step in linking quantum mechanics and the theory of gravity. These kinds of wormhole experiments on quantum computers have drawn significant interest from institutions like NASA and research organizations in Europe. It might be impossible to open a giant wormhole gate in a lab like in the movies, but being able to glimpse its properties at the quantum level is incredibly exciting. Experiments on quantum entanglement and the order of time in other areas. Research is being done on phenomena in the quantum world where the order of time becomes ambiguous. Some experiments have even reported results that suggest an indefinite causal order, where the sequence of cause and effect is not clearly defined. For example, in a certain quantum circuit, it's possible to create a state where it's not determined whether event A happens before event B, or B happens before A. Using this, a kind of time travel-like simulation is possible. A recent research team used entangled photons to conduct a thought experiment simulating a closed time-like curve, or CTC. Specifically, they used quantum entanglement and a teleportation circuit to successfully feed back information to the past to improve an outcome after seeing the result. It's like a strange process where you get to see your graded test and then go back and change your answers. Again, this isn't a case of a person actually going back in time. It's just manipulating the state of qubits. However, the ability to probabilistically show that a past choice can be improved is an interesting result when considering the relationship between time and the quantum world. As you can see, at the forefront of quantum experiments, the very concepts of temporal order and causality are being questioned. This is still fundamental research, far from any practical application, but it might hold clues to resolving the paradoxes of time travel using quantum theory. Time crystals, the time structure of the quantum world. As another recent topic, let's touch on the concept of quantum time crystals. Simply put, a time crystal is a state of matter that has a repeating structure in time. Normally, in the ground state of matter, its most stable state, nothing changes, and everything is at rest. But in 2012, Nobel laureate physicist Frank Wilczek proposed that it's theoretically possible for a substance to continue a periodic motion, even without any exchange of energy. This is a time crystal. It's a presence that spontaneously breaks time translation symmetry, the idea that the laws of physics are the same at any given time, and can be thought of as a crystal structure in the dimension of time. Initially, there were counter-arguments that time crystals were theoretically impossible. But starting in the mid-2010s, experimental verifications were reported, one after another, by periodically driving ions with lasers or using superconducting qubits. Scientists were able to create quantum states that continued to oscillate perpetually without a continuous supply of energy from the outside. For example, there was an experiment where two time crystals were created within superfluid helium-3, and they continued to oscillate stably for over 15 minutes. This was a result that overturned conventional physics, as it showed motion continuing in a stable state that was previously thought to be absolutely still. It looks like perpetual motion in a closed system, but it's a phenomenon that takes advantage of a loophole in quantum mechanics, which allows for it, as long as it's not being observed. Time crystals themselves are not directly related to time machines. However, the discovery that it's possible to give time a structure is deepening our understanding of the concept of time and raises hopes that humanity might be one step closer to technologies that can manipulate time at will. In fact, research on time crystals is also expected to contribute to the development of quantum computers. There are ideas to link multiple time crystals to exchange information, which could dramatically improve the coherence or stability of the quantum state of qubits. In short, from the perspective of controlling time, time crystals are a very interesting phenomenon. You could say it's an attempt to bring a new kind of order to the axis of time. So far, we've looked at everything from future time travel to the past, and the latest theories and experiments. To sum it all up, a journey to the future is already theoretically possible, while a journey to the past, though not ruled out by theory, is fraught with challenges. At the same time, our understanding of time itself is changing significantly. Modern science is beginning to treat time not just as a static background, but as something dynamic. And through quantum experiments and the creation of new materials, we are searching for hints on how to manipulate it. What was once considered fantasy is now a subject of serious scientific discussion. The philosophical and social impact of time travel. If a time machine were ever realized, what would happen to human society? Let's shift our perspective a bit and consider the philosophical and ethical problems of time travel and its impact on society. Even if science shows that something is possible, whether we should actually do it is another question entirely. If journeys to the future or past become a reality, we might be opening a new Pandora's box, the morality of changing history. The first thing that comes to mind is the ethical dilemma of whether it's right to go back to the past and change history. For example, if you could go to the past with a time machine, everyone would at some point think about preventing a tragedy or stopping a war. An extreme example is the famous debate about whether one could prevent World War II by stopping Hitler when he was young. But is it permissible to intervene in history like that? At first glance, it might seem like a good thing for humanity. But altering history could have unforeseen side effects. This is the so-called butterfly effect, where a small change could trigger a chain reaction of massive changes in the future. If Hitler were gone, another person might rise to power and create an even worse world. Or, by preventing a war, technological innovation might stagnate, leading to a different kind of disaster for humanity. A well-intentioned intervention doesn't always lead to a good outcome. Furthermore, our very existence today is the result of the accumulation of all past events. If someone changes the past, it could be equivalent to erasing the existence of people living in the present. What if you were on the side of being erased? Would we be able to accept someone else unilaterally altering the world in which we exist? A time traveler interfering with the past is, in a sense, stepping into the realm of the gods, and it poses a deep ethical question to us all. Questions of causality and free will. If time travel becomes possible, it will also raise fundamental philosophical problems. These are the problems of causality, the order of cause and effect, and free will. Normally, the order of causality flows in one direction, from past to future, but with time travel, causal loops could form, or effects could precede their causes. This would shake our worldview that everything has a cause. If you could send information from the future to the past, then theoretically, the result could be determined first, with the cause following later. If that were the case, it would become even more difficult to answer whether human actions are truly chosen by one's own free will. If, as Novikov's self-consistency principle suggests, history cannot be changed, no matter what you do, then that is an extreme form of determinism and a denial of free will. On the other hand, if you can freely change the past, the network of causality would branch out and become a complex system, where it might no longer be possible to define a true cause or a true result. The possibility of time travel will shed new light on philosophical themes that have been debated for centuries, such as fate and free will, determinism and probability. Even questions about the meaning and purpose of human existence might need to be re-examined in the face of time travel. This is because the very fact that we are bound by the flow of time is a premise for our outlook on life and our values. If we could control time as we please, how would the meaning of life and the meaning of history change? It's a grand question, but one we cannot avoid. Impact on religious and belief systems. Since ancient times, humanity has held various beliefs about time. Many religions see time as linear, with a beginning creation and an end apocalypse. On the other hand, some, like Buddhism and Hinduism, interpret time as cyclical, with periodic creation and destruction of the cosmos. But in any case, it is not normally believed that humans can change the flow of time when a time machine is realized. It could shake these religious worldviews. If a person could see the future, which was thought to be known only to God, or if they could rewrite the past fate determined by God, would that be considered blasphemy? Or would even that be part of God's plan? Time travel could be strongly condemned as an act of humans stepping into God's domain. Also, concepts like prophecy would lose their color. If someone from the future brings knowledge from the future, the authority of traditional scriptures and prophecies might decline. Conversely, if it turns out that a figure from mythology was actually a person from the future, a new faith might be born. Humanity's long-standing philosophical and religious reflections on time will be forced to undergo a major transformation in the face of a real-time machine. Social impact and risks. The social impact of time travel technology would be immeasurable. The first thing to consider is its misuse for crime. If someone could go back to the past, they could commit a crime and immediately hide in the past, or perhaps even make the crime never have happened. It wouldn't be impossible for someone to commit a murder and escape to the past living under a false identity in that era. Or unethical historical interventions could occur, like going back to before a rival company was founded to sabotage it, or altering the world so that a competitor never existed. The impact on the economy would also be devastating. Going to the future to find out stock price trends or the results of horse races and using that information to make a fortune in the present is the ultimate form of insider trading. The market would be thrown into chaos, and the reliability of the economic system would collapse. Also, if only the wealthy were to monopolize time travel technology, there are concerns about the extreme maximization of inequality, as they could monopolize information about history and the future to further increase their wealth. If those in power were to interfere with the past and rewrite history to their advantage, democracy and everything else would be meaningless. To maintain social order, strict regulations and surveillance on time travel would be necessary. Things could even get to a point where a time patrol or time police is established to crack down on historical alterations, leading to a dystopian world. It sounds like science fiction, but if a time war were to break out between time travelers, with battles to rewrite history, all of humanity would be caught in the crossfire. In the worst-case scenario, a war over a time paradox could cause the timeline to split, or our entire universe could collapse. The possibility is not zero. Another ethical point to consider is the journey to the future. If you only go to the future, there's no worry about altering the past. But now you have the Rip Van Winkle problem. If a large number of people were to travel to the future, the remaining society's labor force and population balance would be disrupted. Conversely, if people were to return from the future to the present, which is theoretically possible in relativity but technically difficult for a round trip, a large number of future people could suddenly appear and strain the social infrastructure. Furthermore, bringing knowledge and technology from the future society into the present would cause an information flood. This could lead to the collapse of the current technological system and culture and cause panic. Thus, the social risks of time travel could be even greater and more unknown than those of nuclear weapons or AI. Nuclear technology brings physical destruction, but time travel technology has the potential to rewrite reality itself. It truly is a Pandora's box, and once opened, it would be extremely difficult to go back. Therefore, even if it becomes scientifically possible, humanity will need to carefully debate whether to use it. International ethical guidelines and treaties will be required, including even the option of not developing it at all. The meaning of human existence and the good and evil of technological progress. From a philosophical perspective, the last thing I want to touch on is the question of the meaning of human existence and the value of technological progress. The debate over time machines is ultimately a theme of how close humanity can get to being gods. Manipulating time is something that, in myths and legends, only gods and magicians could do. If human technology makes that possible, we will, in a sense, obtain the power of a god. Is that a good thing for humanity? Technological progress has always brought both light and shadow to humanity. By obtaining fire, civilization flourished. But the danger of fire also arose. By obtaining nuclear power, we gained enormous energy, but we also created the threat of nuclear weapons. Time travel technology will also contain both extreme good and evil. With knowledge from the future, we might be able to cure diseases and save many lives. But in trying to prevent a genocide by changing the past, we might cause another tragedy. Some say that technology itself is neither good nor evil, and it depends on the people who use it. But for something with risks as great as time manipulation, its very existence could become an evil. Also, if time travel becomes possible, the question of what is life will also change. It is often said that life has a once-in-a-lifetime preciousness, precisely because it cannot be turned back in time. It was human destiny to live with our failures and regrets. But if we could have as many do-overs as we want, what would happen to human codes of conduct and morality? If mistakes can be undone, people might become more prone to making them lightly, or, conversely, they might live a life of repeated trial and error in the future, choosing only the best results. In any case, with the premise of a once-in-a-lifetime existence crumbling, human psychology and social order will change dramatically. Ultimately, humanity, having evolved into beings capable of time travel, may no longer be human in the sense we currently understand. We will need to think more deeply than ever before about the balance between technological progress and ethics, and whether such a post-human future is desirable or something to be avoided. In conclusion, we have taken a whirlwind tour through the possibilities of time travel and its scientific, philosophical, and social aspects. What we can say, as a result, is that travel to the future is theoretically possible. And in fact, we are always moving toward the future. The surprise of relativity was that we could dramatically increase that speed using high-speed travel or gravity. On the other hand, travel to the past is an unsolved mystery. The general theory of relativity has solutions that allow for it, but it is fraught with the major problem of paradoxes, and there are many unknowns from a quantum theory perspective. Science does not have an answer right now. Will it be impossible, as Hawking predicted, or will a groundbreaking theory in the future overcome the paradoxes? The interest is endless. In any case, understanding time itself is undoubtedly one of the greatest challenges for humanity. Unraveling the nature of time is a profound question related to the origins of the universe and the nature of our consciousness. Research into time machines is by no means a far-fetched dream, but one way to approach this grand question. If you could travel through time, what era would you want to go to? A few hundred years in the future, or a certain moment in history? Please let me know in the comments section. I look forward to hearing about your time travel plans. Just thinking about the wonders of time can broaden our horizons and give us an opportunity to reflect on how we live our lives in the present. Thank you for watching until the end. If you found this video interesting, please be sure to subscribe and give it a thumbs up. Also, this channel, Cosmic Lab, has been able to grow steadily thanks to the support of all of you watching. Thank you so much for your continued support. We have set a challenging goal of reaching 100,000 subscribers by the end of 2025. And we are working hard every day to create videos. If you haven't subscribed yet, please do so and continue to support us. We would really appreciate it. Well then, we'll be waiting for you in the next video.